Just kidding. You were messing with the volume, weren't you? If you've haven't heard that joke or seen that joke in the past, get used to it. I'll probably tell that one about every 10 videos because it's so funny. My name is Mr. Krause. If you're just curious, I am from Hilton, CSD. That's near Rochester. It's a suburb of Rochester. My partner in crime is Miss Newman. And guess where she's from? Oh yeah, Hilton Central School District. And we are www.NK Newman Krause Infinity.com. Hey, listen, if you're watching my videos and you're using my videos, please, I hope that you're using them appropriately. I keep forgetting to give this warning out, but I don't know if I have to. You're 11th and 10th and 11th and 12th graders. I don't know if you need to be told, hey, don't just copy what I'm doing. Though these are notes, and you're probably supposed to copy most of them, but once you get the gist of things, pause the video, try the problem on your own and see if you get the right answer. Now, you can always scrub to the end of the problem, see if you got the right answer. If you didn't get the right answer, back up and see how you did. Okay, if you think I made a mistake, let me know about it. Don't be mean. Just say, Krause, you're an idiot. You screwed something up. Fix it before I have to call the math nerd police. I don't even know where that stupid thing came from. But anyway, my name is Mr. Krause. You can call me Mr. Key for the next, half an hour or so. This little review from yesterday. I'm going to blow up a little bit more. Let's go 300%. It just looks a little bit better. You can see it a little bit better. Okay, so we'll rewrite this. This is a square root, so we're going to rewrite it as all perfect squares and not perfect squares. Well, 81 is, in fact, a perfect square. X squared is a perfect square. Y cubed is not, so we're going to rewrite it as y squared, y. And then z to the fourth. Remember, when we're looking for perfect squares, we are looking for even exponents, multiples of 2. Square root of 81 is 9. The square root of x squared is x. By the way, this one you should have done on your own. So if you're not doing these on your own, these ones you should do on your own. So to the next one on your own. Y squared is y. Z to the fourth is z squared. So my final answer is 9xyz squared square roots of y. Oh, look, the exact same problem, except it's a cube root. So we have to do things a little bit differently. We're looking for a perfect cube that goes into 81. And that would be, 27 times 3. Now we're looking for multiples of 3. Well, I can't do anything with x squared. It's just x squared. Y cubed is a multiple of 3, so I will just leave that. And z to the fourth can be written as z cubed and z. Remember, now we're looking for multiples of 3. The cube root of 27 is 3. The cube root of x... Oh, wait, hold on a second. I can't take the cube root of x squared. Oh, I got it. The cube root of y cubed is y, and the cube root of z cubed is z. So my answer is 3yz cube roots of 3x squared z. Okay. Oh, look, the exact same question, but it's a fourth root. So we're going to rewrite it. Now, let's see. Is 81 a perfect fourth? It is. It's 90. I just got back from a 5-mile walk. I'm drinking water. And it's 8 o'clock at night, so I'm drinking water. So 81 is a perfect fourth. Oh, I almost forgot my 4 here. X to the squared, can't do anything with it. Y cubed, can't do anything with it. But z to the fourth, that's a perfect fourth, but it's already perfect fourth. So I really didn't even need to rewrite anything. The fourth root of 81 is 3. And I can't touch this, can't touch it, can't touch this, can't touch this. And z to the fourth is just z. So I end up with 3z fourth roots of x squared y cubed. Now, you should be able to tell me why that answer is correct and this answer is wrong. Can you tell me why this one is right and this one is wrong? How about this one? Maybe I'll make it a little bit more obvious. Can you see it now? See, the problem is this is clearly a fourth root. I've stuck that 4 right deep in here. This one looks like it belongs to the z. Maybe it belongs here. I don't know. You need to make it clear. 3z, leave a space, the fourth root, put it right in there, of x squared y cubed. Just be careful the way you write your answers. You don't want to lose points for not writing your answers the correct way. All right, today we're talking about multiplication, addition, subtraction, and division. Sounds like fun. All right, let's go. Here we go. Here we go. Here we go now. Here we go. Here we go. Here we go now. Looks like I'm about to unmaximize this thing. All right. So simplifying all radicals. How cool is that over there? That looks pretty wild. It looks better on my sheet. This is kind of a mess, but whatever. Simplifying radicals. Simplifying all radicals. So if you're going to add or subtract, the first step is to simplify radicals. This is like step 1, simplify. And why? It's just easier. So here we go. Add and subtract. If they have the same exact radical, you can just simply adding them up. This is equivalent to or similar to adding 3x plus 4x. You can just add those up and get 7x. Well, in this case, you get 7 square roots of 3. Now, I wrote square roots of 3. So it's 7 square roots of 3. It's like a square root of 3, square root of 3, square root of 3, plus square root of 3, square root of 3, square root of 3, square root of 3. Well, what do I got? I got 7 square roots of 3. Over here, they're exactly the same. As long as this and this are exactly the same, I can add them up, and I get negative cube root of 5. I could put negative 1 cube root of 5 if I want, but that's kind of boring. Don't need that. So, multiplying. I think all we're doing is adding, subtracting, operations. I don't know how much division we're going to get through today, but let's just see. All right, we're going to distribute here. So we're going to distribute here. So I got to multiply this times this. Now I know you've already done this in algebra, so some of this stuff should be review. You're going to multiply the outsides together and the insides together. So 2 times 3 is 6 square roots of 18 minus 2 times 3 is 6 square roots of 9. Now, do you see what the last thing says here? It is my answer in simplest form, because if it's not, you're going to have to simplify it. So that last step is to simplify. So let's do that real quick. This is really 6 square roots of 9 times 2 minus 6 times, well, square root of 9 is just 3. So the square root of 9 is 3. So this is 18 square roots of 2 minus 18. Now notice the second one does not have a radical on it. Therefore, you can't do anything with this. Now, sometimes kids want to know, hey, did I get the right answer? So let's take the original. Let's do this. Let's do the original. So let's take the original. Now, the original was 2 square roots of 3. 3. Parentheses. 3 square roots of 6. Now, this is a great check, but don't you dare turn this in as an answer. I always get some muckety-muck goofball that thinks that the answer that this is going to give is the answer actually a trig teacher or an algebra 2 teacher wants. Oh yeah, Mr. Krause, the answer is 7.4589441. What? And then the question is find the exact value, so they figure if they write all the decimals down, that's the exact answer. Please don't be that person on a test someday. I mean, really, truly, that's the one time a teacher should allow to slap you. Not to hurt you, just to wake you up out of your deep funk. Now, let's type in the answer here. And by the way, I'm not advocating hitting kids. For those like, oh my God, Mr. Krause wants to hit kids. Well, there's been a couple. Over the years, 20 years of teaching. So 18 square roots of 2 minus 18, I just hit enter. Look at that, the same exact radical. So it's a real quick check to see, at least does your answer match the original. All right, let's work on this one. Oh, this is multiplication. So what we're gonna, these are both cube roots. And they're both the same cube root, so I can multiply those together. What I end up with is the cube root of 250. But did I simplify my answer? I got to check. Is there a perfect cube that goes into 250? And of course there is, otherwise it'd be a boring question. 125 times 2. And what is the cube root of 125? It's 3. So my answer is the cube root, excuse me, just don't have any room down here. Let me give you my answer. It's 3. By the way, the cube root of 125 is clearly not 3. It's 5. 5 cube roots of 2. Now, had I screwed that up, I could come over here. I go the cube root, oh shoot. The cube root of 5 times the cube root of, that was weird, cube root of 50. I get an answer. There it is, 6.2999. And then I said, I originally was going to say 3 times the cube root of 2. And I'd say, wait a second, that doesn't match. What did I do wrong? And of course, what I did wrong was, this shouldn't be a 3. It should be a 5. So this is a way you can say, hey, I made a mistake, but wow, oh, I checked it. Now, look, it's right, and it's right. Same answer here. Same answer here. Perfect. All right, there's my answer. Nothing like ice cold water in a cool Dunkin' Donuts cup. I was thinking about getting like an coffee culotta with my Dunkin' Donuts K-Cups, but by the way, I get no money from Dunkin' Donuts. If you think I got Dunkin' Donuts sponsor, you're crazy. But if you know somebody that owns Dunkin' Donuts and would like to sponsor me, I just want free coffee. I'm just kidding. I want millions and millions of dollars for this YouTube channel. That's so awesome. Whatever. All right. So let's see here. Do you remember my directions were to simplify first? See, if I took this thing and I multiplied 18 times 27 and got, 18 times 27. What am I doing? Enter. Okay, 18 times 27. That only took me an hour to do that. I get 486, and then I got to simplify 486. That's just too much work. So I want to simplify ahead of time because it's just easier working with smaller numbers. So let's do that first. Square root of 18 is 9 times 2 x squared x times the square root of 9 times 3 x to the 4th x. All right, let's see what we got here. 3, and this is 3, and this is x, and this is x squared. All right, so this is 3x square roots of 2x times 3x squared square roots of 3x. So just like I said before, we're going to multiply the things that are outside together, and then we're going to come through and multiply the things that are on the inside together. So let's multiply those outside stuff. I get 9x cubed square roots of 6x squared, because 3 times 2 is 6, and then x times x is x squared. But remember, that last step is just check. Is everything simplified? Oh, wait a second. I can take the square root of x squared. That's just x. So my final answer is 9x to the 4th square roots of 6. And again, if you want to, can I check this? How am I going to check this? It's not numbers. Let me show you a way to check this answer. And this is kind of cool, so pay attention. I'm going to take any number. Now, I don't pick any normal number. I'm going to pick like 3.1. It really makes no difference because the calculator is going to do all the work anyway. Like if I had to do it, I'd pick 9. If I had to do it by hand, I'd pick 9 or something, some nice perfect square. But I'm just going to pick 3.1 and I'm going to stow it, control var into x, whatever variable they chose, x. And now I'm going to type in the original, the square root of 18x cubed times the square root of 27x to the 5th. So that was my original problem. Some big number. There it is, 2,000. Who cares? I don't care. Now I just want to see if my answer matches it. So I'm going to do 9x raised to the 4th square roots of 2. It does not. It does not match it. So I must have made a mistake. Oh, it's not square roots of 2. It's square roots of 6. Woo, man. I was going to say, I didn't think I made a mistake. I thought I was right. So, okay, so you got to type it in right. 6. Hopefully this matches that 20. Ah, there it is. 20, 20, 35 up here. 20, 20, 35, 20, 35 there. It matches. That's a real nice way to check. Now, clearly, I can't just say, I can't use that cheat to get to that answer. I still have to know what I have to do, but using that little cheat helps me tell if I got the right answer. All right, outsides together, insides together, but we're going to clean this up first. So these are cube roots, so we're looking for perfect cubes, so this is 5. Notice I'm going to put this 3 right down in that little crux. And then let's see, -8 times 4. Now you're thinking, well, 4 is a perfect square. I know it's a perfect square, but we're working with perfect cubes, and 8's a perfect cube, 4 is not. Times a times b squared. And then this is times 2 cube roots of, well, I can't do anything with any of this. A squared b. So this actually might have been an easier one just to multiply ahead of time because these aren't bad numbers. I'll show you that too. You could have done it that way as well. So let's see. This is -2. It's a cube root. Remember, I's only deal with square roots. This is cube roots. And then I can't do anything else. So I did all that work just to get that -2 out. So this is kind of a pain in the neck. So -10 cube roots of 4ab squared times 2 cube roots of 1/2 a squared b. Actually, this is the longer way to do this problem, but whatever. So we're going to multiply the outside stuff together. I get -20. And then we're going to multiply the inside stuff. 1/2 times 2 or 4 is 2. A cubed b cubed. All right. Oops. Well, the cube root of this is a. The cube root of this is, that looks like a 9, doesn't it? A, and this is b. So my answer is -20 a b cube roots of 2. Now that seems, I'll bet there's an easier way. Sometimes it's easier, and sometimes, like I looked at these problems and I said 18 times 27. That's huge. I don't want to do that. But this one, it's small numbers. Maybe I just want to multiply the outsides, and I'm going to do this all over again. I'm going to see if I arrive at the same answer. I'm going to pick purple because purple tells me I'm going to do the cool question. So 5 times 2 is 10. Now I'm going to do the square root. -32 times 1/2 is -16. A cubed b cubed. Okay, so this is 10. Oops, cube roots of -8 times 2 a cubed b cubed. -2 a and b. So I end up with -20 a b cube roots of 2. Same answer. You can do it either way. Sometimes it's easier to simplify ahead of time. Sometimes it's easier to simplify afterwards. Adding and subtracting sometimes a little bit trickier because I'm going to get some goofball. Oh, I'm in trig, and so what I'm going to do is I'm going to take 6 and subtract 3 and then add 8, and I get like 11. And then I'm going to take 24, I'll subtract 96, and I'll add 50. Come on, seriously? Come on, this is trig, kids. You got work to do. Nothing's going to be that easy. This ain't 4th grade math. You ain't doing that. So we have to simplify each of these. And remember, in order to add radicals, the radical has to be exactly the same. Exactly the same. So let's see what we got here. We're going to simplify each of these. So 24. 4 times 6. I'm just going to finish this one. The square root of 4 is 2. So this becomes 12 square roots of 6 minus 3 16 times 6. Maybe you didn't know 16 went in, but I knew it had to be a 6, or I thought it had to be a 6, because it wants to match. You want to have the match. The square root of 16 is 4, so this gives me 12 square roots of 6 plus 8. Now remember, I just said we want to have a 6, right? So this is probably, what, 9 times 6? The square root of 9 is 3, so this is 24 square roots of 6. All right, let's see. 12 square roots of 6 minus 12, those go away. And I end up with 24 square roots of 6. And again, you can use your calculator to check your work, but that's right. All right, these are perfect cubes. Remember, you have to have the, I'll still get this kid to go, oh, the answer is 3 cube roots of 38. Yeah, that's it, because I just subtracted. Maybe Algebra 2 is not the right place for you if you're doing something. If you actually think something's going to be that easy in Algebra 2, it may not be the right place for you. So we're looking for perfect cubes. We've done 54 already a couple of times now. You by now should know this is 27 times 2. The cube root of 27 is 3. That's 15 cube roots. Notice where I put the 3. Cube roots of 2. Minus 2 cube roots of 8 times 2. The cube root of 8 is 2. So this is minus 4 cube roots of 2. Now, these don't match. You can't do anything. They have to match. They have to be exactly. And 15 minus 4 is 11 cube roots of 2. Remember, treat the radicals as if they're just variables. They don't add or subtract unless you're multiplying. All right. So yesterday we learned, why am I not able, oh, wrong button. Yesterday we learned about I. I love math. Remember, square root of -1, heart math. I heart math. It's a great joke. You can tell your friends and neighbors. Remember to tell them where you got it from, nkinfinity.com. Don't tell them that, because I really would like them to come to my website, not hate me. All right, so anyway, I love math. Anyway, operations with complex numbers. So yesterday I talked to you about imaginary numbers, like, oh look, I have an imaginary friend. Its name is I. Yeah, well, we're going to go over here. Have fun, buddy. Whatever. Now we're going to take that and expand it to complex numbers, because numbers weren't hard enough. We make them imaginary, and then we make them complex. All right, here's all this means. First of all, generally what you're going to see is somebody says, put your answer in A plus or minus BI form. This is a number that's complex. Now, why is this complex? It's complex, first of all, because you don't know what the hell it means. Heck, it means. But it's complex because this is a real number, some real number. Not an imaginary number, it is a real number. It's a decimal, a radical, a fraction, something. This, however, is an imaginary. This is the imaginary piece. So if I take a real number and I put it with an imaginary number, I get complex numbers. And that's what we're going to deal with. Our answers now are going to be complex. Easy, but complex. All right, so add these up. I get 9 plus 3i. Huh? That wasn't too complex. What's a common mistake? Accidentally accidentally multiplying. You see two parentheses and you're like, oh, I know, double distribute, FOIL, multiply, yeah. No, it's just a plus. I mean, look, there's a plus right there. Just add them. All right, so this one, anybody know what the common mistake is before I go on this one? That's right, forgetting to distribute the negative. One of the things that separates the really exceptional math students from the average to the below average is students that can recognize where other students are going to make mistakes. If you look at this problem and the first thing you say is, oh, alert, alert, there's a negative to be distributed. Oh yeah, I know people are going to make that dumb mistake. You're going to be a better math student. So as we go through these videos, I'm going to try to point out areas where, hey, kids are going to make mistakes here. Hey, kids are going to make mistakes here. And you then hopefully will grow as a student and won't make that mistake. I'm hoping. Some of you, it's like my hair. It ain't going to grow into anything great, but we're working on it. So keep trying, kids. Keep trying. So let's distribute that negative. Chink, chink. So I get 6 plus 3i minus 4 plus I. So I distributed the negative. Now I put them together. 2 plus 4i. Done. All right, so this one is multiplying, so we've got to double distribute. So we're going to multiply 2 times negative 5, we get negative 10. The common mistake, I'll tell you about that one in a second. 2 times 2i is plus 4i. I times negative 5 is negative 5i. And I times 2i is plus 2i squared. So if I clean this up, I get negative 10 minus I plus 2i squared. But that doesn't look like the form I told you it had to be in. I want it to have a constant or a real number and one imaginary number. I don't want all this extra stuff. By the way, plus or minus just means because one can be plus, one can be minus. Here's the common mistake made on this, and this is something we talked about yesterday, and that is when I introduced I to. And what did I tell you is probably the most important thing you remember about that I circle? Remember that I circle? Let's practice it. I to the first is just I. I squared, do you remember what it's equal to? Negative 1. I cubed is equal to the opposite of this, negative I. And I to the fourth is opposite of this. It's equal to 1. So, I to the first is just I squared is negative 1, I cubed is negative I, and I to the fourth is 1. But I told you the most important thing probably was going to be this one right here. And it comes up in math problems repeatedly. And that is the fact that I squared is really negative 1. So you forget to sub in negative 1 for I squared. So this becomes negative 10 minus I plus 2 times negative 1. Well, 2 times negative 1 is just negative 2. So if I put that together with this, I get negative 12 minus I. And just for fun, because I want to share with you this calculator, how cool this calculator is, it will do all that math for you. Now, I'm only sharing this with you as a means to check. Your math teacher should make a problem that you have to show your understanding of the I's. Because if you don't know how to show, you got to be able to show your understanding of the I's. But the calculator can help. 2 plus I. It can tell you if you're right. Use it as a check. Don't use it as a cheat. Where are you going with that? What are you going to do with that? Okay? Use it as a means to check your answer, not cheat. And what was the other one? Negative 5 plus 2i. Negative 5 plus 2i. And if I hit enter, I get negative 12 minus I, and that's what I came up with there. See? Not too bad so far. Okay, so it's really practice time. So we're just going to keep going through these. You know, at some point, I'm hoping I got lots of practice problems. What do I got? 20 practice problems here for you. And at some point, I hope you're getting good at these. All right, so let's just get through these. Let's see how you do. All right, so 2 cube roots of 8 times 3. Well, the cube root of 8 is 2, so this is 4 cube roots of 3. Now, if this is going to work, this one better have a cube root of 3 as well. And, oh, look, it's got 75, so we know that's got to be something with 5s. And 5 cubed is 125. So 125 times 3, the cube root of 125 is 5. So I get minus 25. You see it right here? The 5's multiplied. Cube roots of 3. And now that they have the same radical, exact same radical, I can add them up. I get negative 21 cube roots of 3. All right, so 16 times 3 minus 9 times 3 plus 4 times 3. Notice they all have a 3. This is 4, this is 3, this is 2. So this is 4 square roots of 3 minus 3 square roots of 3 plus 2 square roots of 3. So 4 minus 3 is 3. 4 minus 3 is 1. 1 plus 2 is 3. Radical 3. Multiplying. Now multiplying, I can just multiply. Let's just multiply. So I get the cube root of 24x to the 6. But you still got to simplify. 8 times 3. And x to the 6th is a perfect cube already, so I don't need to mess with that. The cube root of 8 is 2. The cube root of x to the 6th is x squared. So 2x squared cube roots of 3. Now you should never ever get these wrong, because if you're not lazy, you can always come over here to your calculator and check these. Again, I'm just going to remind you, don't put a normal number in. Put in something like 6.23. Who cares? The calculator's doing all the work. Store it into x, or whatever variable's being used, and we're going to type in the cube root of 8x squared, 8x squared. Now this by no means can be used to solve this problem. It's3 the cube root of 3x to the 4th, 3x raised to the 4th. Enter. You get some just dumb number, obnoxious, who cares? Now check your answer. 2x squared cube roots of 3. Hopefully it's the same. Should never get these wrong, because right there you can check. Hey, I got it right. I'm done. Got it. Yay. I'm not going to check anymore, but you hopefully have learned how to check with those. All right. So let's get to these. 4 square roots of 9 times 2 plus 2 square roots of 25 times 3. That's weird. Minus 2 square roots of 9 times 5. That's weird. Minus 4 square roots of 25 times 2. So I simplified them, but I think I'm going to have an issue. I got to see what's going on here. Square root of 9 is 3, so this is 12 square roots of 2. Square root of 25 is 5, so this is plus 10 square roots of 3. Square root of 9 is 3, so this becomes minus 6 square roots of 5. And the square root of 25 is 5, so this is minus 20 square roots of 2. Now remember, you can only add radicals that are exactly the same. So I got a square root of 2 here and a square root of 2 there, but nothing else matches. So those are the only two things I can put together. 12 minus 20, negative 8 square roots of 2 plus 10 square roots of 3 minus 6 square roots of 5. That's it. Next problem. All right, we're just going to distribute. So I get negative 36i minus 20i squared. Whoa, 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 whoa. Do you remember? Do you remember? What is I squared really? It's really negative 1. So this becomes 20. And they always want you to put your answer in a plus or minus bi form. So always put the real number first and the imaginary number second. So the real number is this positive 20 minus 36i. That's your answer. That's your complex number. Now, if you just think about it, I squared basically just changes the sign of whatever it's with because it's just multiplying by negative 1. Let's double distribute. These are conjugates, so I really don't have to because the middles are going to fall, but we haven't talked about that. Oops. Forgot to do this first. 2 times 2 is 4. 2 times negative I is negative 2i, positive 2i, and then positive I times negative I is negative I squared. Well, if you remember, these are canceling. Now, if you learned something in 9th grade, these things are called conjugates. The middles always fall out. So what I end up with is 4 minus I squared. But isn't I squared really negative 1? So this is 4 minus negative 1, which is really plus 1. Okay, we're flying, kids. We're going. Hopefully, you should be pausing this. You really should be pausing this and trying these on your own. What's the common mistake here? Common mistake here is thinking you have to multiply. This is an easy problem. You don't have to multiply. You got 3 plus 8. That's 11. Minus 4 and minus 2 is minus 6i. Done. Problem's over with. Here we got to distribute. So I squared times 1 is I squared plus I squared times 7 is 7i cubed. So this is just negative 1, but this I got to deal with. Remember the I circle. I to the 1 is just I. I squared is equal to negative 1. I cubed, which is down here, is negative I, and I to the 4th is equal to 1. I know that I cubed is really negative I, so I have to replace that. It's not okay to leave it like this. Not okay. You have to simplify it. So I cubed is really negative I. So my final answer is negative 1 minus 7i. This I have to double distribute. 1 times 3 is 3. 1 times I squared is plus I squared minus 3I squared minus I to the 4th. So this becomes 3 minus 2I squared minus I to the 4th. I need to do some subbing. So this is 3 minus 2. What is I squared again? Negative 1. Now I just did the I circle for you, and I went to I to the 4th for a reason. What was it? Do you remember? What was I to the 4th? 1. So I'm going to replace that with I to the 4th, which is really 1. So what I end up with here is 3 plus 2 minus 1, which is just 4. 4. That whole crazy thing right there just turned out to be 4. Oh yeah, you don't believe me? Let's check. So parentheses, 1 minus I squared, 1 minus I squared. Well, I don't even have anything in parentheses. Parentheses, 1 minus, it's like you can go through the whole thing, you're not even paying attention to what you're doing. I squared, parentheses, 3 plus I squared, plus I squared, 4. Now, it is not okay on your test, not okay to go from here to here without showing some work. All right. Again, you need to understand, but it's a great check. All right. It's just, common mistake, not distributing the negative. Common mistake. So this is 6 minus I minus 12 minus 8I. 6 minus 12, negative 6. Negative I minus 8I, negative 8. Negative 9I. All right, we're halfway done with these problems. Let's keep going. Double distribute. Don't get scared. The square root of x times the square root of x is the square root of x squared. Square root of x times negative 6 is minus 6 square roots of x. Hopefully you start recognizing conjugates. Notice they're exactly the same. One's plus, one's minus. When this happens, the middles always fall out. The middles always cancel. And then positive 6 times negative 6 is negative 36. Well, what is the square root of x squared? It's just x. So this becomes x minus 36. All right, double distribute. Remember, insides get multiplied, outsides get multiplied. So this becomes 5 square roots of 4 plus 20 square roots of 12 minus 3 square roots of 12 minus 12 square roots of 36. All right, so we got here. This is 2, and this is 6. So this becomes 10. These can be combined. Plus 17 square roots of 12 minus, what's 12 times 6? 72. So I can put these two things together. That gives me negative 62. But I still got to simplify this square root of 12. Square root of 12 is 4 times 3. Square root of 4 is 2. So this becomes negative 62 plus 34 square roots of 3. All right, I think we got 8 left, kids. Let's see how fast we can get through them. Again, you shouldn't be doing these with me. Oh, went to the last packet for some reason. You should be doing these on your own and checking your answers. You should be pausing and checking your answers. This is 2 cube roots of 5, nothing to do there, plus 3 cube roots of 8 times 5. The cube root of 8 is 2. So this becomes 2 cube roots of, see how I wrote that poorly? 2 cube roots of 5 plus 6 cube roots of 5. Well, 2 cube roots of 5 plus 2 cube roots of 5 I got the wrong answer. My answer key is the wrong answer. 2 cube roots of 5 plus 6 cube roots of 5. Oh, I did squared. I did 3 squared. 6. So this becomes 8 cube roots of 5. All right, we're almost done. Square root of 25 times 6 minus 2 square roots of 9 times 3. 5, 3. So I get 5 square roots of 6 minus 6 square roots of 3. That's it. Can't do any more. Nothing else. They can't combine them because they don't have the same exact radical. What does squared mean? Squared, I'm going to get some bozo that multiplies. I'm going to go 4, and then they're going to square this thing. No, remember, squared means we write the parentheses twice. So this is really 2 minus 3 square roots of x, times 2 minus 3 square roots of x. So squared just means we write it twice. And now we double distribute. 4 minus 6 square roots of x minus 6 square roots of x. Those don't cancel. One's not plus, one's minus. Careful. A lot of kids try to cancel those. And negative 3 times negative 3 is positive 9 square roots of x squared. So I've got 4 minus 12 square roots of x. Now, what is the square root of x squared? It's just x. Plus 9x. And that's good enough. You leave it just like that. Holy mackerel. I know I have the wrong answer on this one. I don't even know what the 4th root of 729 is. I think it's something. Oops. The fourth root of 729. Nope. So let's see. Does 3 go into that? I'm thinking 3 goes in that. 729 divided by 3. This is a really strange problem. 243. So this is, and 243 is a perfect fourth, right? If I put into this, 243. No, it's not. I wonder what I meant on this problem, because that's clearly not what I meant. There's got to be a fourth. 81 probably goes in, right? 729 divided by 81. 729 divided by 81. 9. Okay, so this is going to be the square root of 4 times 3 minus the 4th root of 81 times 9 plus the square root of 3. So this becomes 2 square roots of 3 minus 3 4th roots of 9 plus radical 3. So my final answer is 3 radical 3 minus 3 4th roots of 9. I have no idea why I decided to be a jerk and put that question on there. I don't even have it right on my answer key, so I got to fix it on my answer because I don't know what I was thinking. I got the 3 square roots of 3, but I don't know. I didn't bother to do the rest of it. I don't know why. Swallowed the fly. I guess we'll die. All right, here we go. Let's multiply. 4 times 12 is 16. X to the 5th. Y. Z to the 8th. Now we want to write these as perfect cubes. I just wrote 16, and I'll show you why in a second. No, I don't know. Yes. No, I don't know why. This is 48. So now I need the perfect cube that goes into 48. And the perfect cube that goes into 48 is 8. So it's 8 times 6. X to this cubes, right? We're looking for perfect cubes. So x cubed, x squared. Y we can't do anything with. Z to the 6th, z squared. Woo! This one's tricky. So the cube root of 8 is 2. The cube root of x cubed is x. The cube root of z to the 6th is z squared. So my answer is 2x z squared cube roots of 6x squared y z squared. Woo! Man, that was so much fun! All right, kiddies, we got 3 problems left. This is a lot longer than I thought it was going to be. All right, let's get going on this. Oh my goodness. Woo! I'm gonna simplify these before I multiply or add them. Well, I have to. I can't multiply them. I'm going to simplify them. See, common mistake would be to multiply those. So it's y. Now the 4th root, that would be 16 times 2, x to the 4th, x squared, plus 81 times 2, x squared, y to the 4th. All right, let's see. I don't know if I'm going to be able to add these. The 4th root of 16, I should have put a 4 here, is 2. And the 4th root of this is x. So this gives me 2xy fourth roots of 2x squared plus, this is 3 and this is y squared. Oh, this is just y. So I end up with 3y fourth roots of 2x squared. Those cannot, I'm going to repeat, cannot be simplified. And the reason they cannot be simplified is, although these match, although these are the same, this only has y and this has xy. And all of the variables and all of the radicals and all of the exponents have to match. So your answer is just that. It can't be simplified. All right, 2 left. 2 more problems, it's bedtime. Can these be added? Well, they have the exact same radicals. So it's 12 fifth roots of x. And I wrote down 11. 9 plus 3 is not 11. That's weird. All right, now finally, final answer. So this is 6 cube roots of 5 plus 5. I ended on 2 easy ones. Yay! That's it, kids. That's all she wrote. Day 5 is over. I hope you enjoyed yourself. I certainly did. Hit the subscribe button, hit the like button. Let me know how much you appreciate my hairstyle. I mean my mathematics. Goodbye, kids. Have a good evening or afternoon or morning or whatever you're working on this. Bye.